The internet as we know it today, we just take for granted has always been there. But it actually began as a project of the Department of Defense. Was it developed with the idea of if one computer went offline, the other would still be able to function? During the time that this was still a part of the military, other services became available, such as CompuServe, AOL. These were largely dial-up driven, but it gave the public an idea that they could actually access information that was outside their particular computer or location. Once the internet, as we know it today, was handed over to the commercial or private sector, it expanded rapidly. And now we can order pizza online, we can buy movies, we can have things delivered without ever actually leaving our home. So it's very much become a part of the fabric of our lives. And one of the things that we certainly can use for greater benefit. We want to take a look at different ways to access the internet in this particular lesson, and I bet you'll be able to see some things that you're familiar with because you probably use them yourself.
Now, obviously, there are some fundamental principles as to how the internet operates and some of the background that it's helpful for you to know in order to know how to address this. Now, to begin with, the internet began as a restricted, limited use network beginning with what was called ARPANET. This was a project that was implemented by the U.S. Department of Defense, which was later interconnected with other regional networks across the world and became connected using the TCP/IP protocol suite, which we'll talk about in a separate lesson. This network was later transitioned to the National Science Foundation, and hence was nicknamed NSFNet, and eventually was turned over to the private sector for commercial development. Now, commercial internet service providers, both then and now, provided some type of core connectivity. Typically, the hierarchy was you had very global internet service providers, then you had regional internet service providers, and then you would have end users. And while that's changed somewhat, the basic principle is the same. Access to the internet, as far as end users are concerned, has changed substantially over the years, and it's going to be the main core focus of this lesson. But the thing to remember about the internet, it is a globally interconnected network of personal computers and routing devices, as you see pictured here. And this is why it's called the internet, because it's between networks. Inter means between, and this is the globally interconnected network that we all know and use frequently today. The very first type of connectivity that was deployed to access the global internet was dial-up, which used existing analog telephone lines in order to be able to create connections. We just want to take a few moments to examine and look over this type of technology. Now, there are a couple of types of dial-up. The most familiar is going to be what is called analog dial-up. Now, keep in mind that analog dial-up access once ruled cyberspace, beginning with what were called online service providers, such as CompuServe and America Online, and then eventually proliferated into internet service providers. Now, analog modems started out at very slow speeds. I remember 300 BPS and 9600 BPS as being considered extremely fast. And eventually, this topped out at 56 kbps, kilobits per second, which is the maximum. Now, keep in mind that speeds are distance dependent. And the farther away you get from the telephone company's central office, or CO, this is the building, typically a brick building that holds and houses all of the telephony equipment, the slower the speed you'll experience. The basic layout's like this. Of course, you have the global internet and just whatever resource you're trying to reach, such as yahoo.com or amazon.com or something such like that. Then you have the end user, which is typically going to be a PC, a laptop, or something like that. Then there was connectivity created using an analog modem, and a modem stands for modulator-demodulator, and took digital data and translated it into analog tones for transmission across phone lines, voice telephone lines, I might add. At this point, internet service providers used what were called modem banks. The individual ISP that I worked for had individual modems. Eventually, you can actually get these appliances with line cards that are actually modems in and of themselves, but the principle's the same. And then that modem bank that was housed at that internet service provider then had some sort of high-speed connectivity to the internet, T1 and so forth. And this is the basic technology of analog dial-up. It is still considered the most universal access type, but with the advent of different broadband technologies, it's considered largely obsolete and extremely slow by comparison. Another type of dial-up you may have not necessarily heard of is called ISDN, which stands for Integrated Services Digital Network. When AT&T actually owned all the telephony infrastructure, most of it in the US, it actually transitioned the core of the network from an analog system to a digital system. And this ISDN type of connectivity was actually what was deployed in the core. Well, there was a special kind of connectivity through this. There was also a type of direct digital connectivity that was available to end users, and obviously this is digital. So you have the same type of setup where you have the internet and then the particular internet service provider network. Again, some sort of resource that's being accessed, the end user PC, and instead of using a modem, it used a device called a TA, or an ISDN terminal adapter. Rather than creating analog tones, it would actually take the data from the computer and translate it into digital signals that would go across a specialized telephone line, which was called a BRI, or Basic Rate Interface. There were specialized digital modems, ISDN modems, that were actually used. That's not really the technical term, but there was actually a connectivity then to those called the PRI, or Primary Rate Interface. So these BRIs would then connect to different lines in the PRI, which is essentially a T1, and then this would be able to give you up to 128 kilobits per second of connectivity. And there were actually two lines in the BRI, so you had one 64K and another 64K, which would be bonded to 128K. Typically, these were very expensive. You had to pay per minute rates, and by most standards today, it was fairly slow. But it is one type of connectivity in the dial-up realm, because the terminal adapter does dial up like making a call and then drops the call at some point. So analog and ISDN were the dial-up types of connectivity for accessing the internet. As I mentioned previously, dial-up has been superseded by much greater technologies, which are collectively referred to as broadband, and is generally synonymous with a high-speed connection. One of the things that's freely available are a number of different types, and we want to look at a wired broadband connectivity type because there's also a wireless type. There's several types that are important to know and understand so that you can effectively support this in a production environment. The first is called Digital Subscriber Line, or DSL. And when I was actually first starting in the industry, this was just coming out. So sometimes when you adopt a new technology and you're one of the first adopters, you can have some interesting experiences. And certainly a lot of the end users that we supported had some interesting experiences. Now the thing about DSL is it actually uses an analog phone line in order to be able to create end user connectivity. Now we've looked at this familiar model where you have the internet, the service provider network, and then some resource you're trying to access on the PC. In this case, you're using a device called a DSL modem or DSL router. Now, modem is not strictly speaking what this device does, but that's how most people think of a modem. And what DSL actually does is within the voice telephone line, there's a small amount of bandwidth that's used for analog phone conversations, just voice conversations. And then there's an entire amount of bandwidth that sat unused, which was made available for transmitting data across the same phone line at the same time. So basically the point is, using these unused frequencies, it was actually the opportunity to be able to transmit data across a plain telephone line. In fact, sometimes you'll hear just an analog telephone line called a POTS line, which just stands for plain old telephone service. Now, DSL actually uses another wide area networking technology called ATM, or asynchronous transfer mode. It's not generally used in networks anymore, but for DSL, it's part of how it operates. End user authentication is actually performed by PPP over ATM or PPP over Ethernet, depending on how the service provider actually deploys it. Speeds can range from 768K to 7 megabits per second. There's always going to be different upload and download rates depending on the type of technology. And it actually connects to something at the telephone company central office called a DSLAM, which stands for Digital Subscriber Line Access Multiplexer. And basically it aggregates all those analog type of connections and then actually performs the whole data transfer as we talked about. There are several different types of DSL. The first is ADSL, which stands for asynchronous DSL. And this is where the download and upload speeds will vary, sometimes by a substantial margin. And you have SDSL, which you won't see as frequently, and this stands for synchronous DSL because the upload and download speeds are equal. Then you have iDSL, which is more of an ISDN-based DSL. Typically, you're looking at 128K to 192K, very, very low by most modern standards. In any case, this is just some of the basic breakdowns. Now, there's pluses and minuses of DSL. The first is pluses. You use a standard copper telephone line. It's an always-on type of connection, and you can get very high speeds over a fairly inexpensive infrastructure. Now, the disadvantages are, number one, many times you have to have filters put on all of your household telephony devices in order to be able to filter out sort of a hissing sound that you would see if you just plugged in directly. Also, it's distance dependent. Just like dial-up, the farther away from the central office you are, the slower speeds you can get. So when a telephone company says you can get up to, T1 speeds, they're saying something to the effect of your mileage may vary. You may not even get close to that depending on how far away you are. So that's something to keep in mind. Now, just some of the different devices that are used for being able to create DSL connectivity. You obviously have a computer. You have the DSL modem, as we talked about, which isn't really a modem, but is essentially a connectivity device. This plugs into a standard analog phone jack. Then you have these filters, because otherwise you're going to hear that hissing sound. And this is the same basic type of connectivity. Sometimes they'll talk about splitters and splitterless types of deployments, but it's really beyond the scope of what you really need to know or probably ever deal with. But these are the basic components of digital subscriber line technology. Another popular wired broadband technology is what's collectively referred to as cable internet, simply because it's provided by a cable company such as Comcast or Time Warner or some other entity like that. And what this actually does is it uses the same coaxial cable that carries all of the television stations you might watch to actually transmit data. In essence, data is transmitted across another channel, logical channel, across the particular type of infrastructure. You have the same basic setup we talked about with internet service providers. Instead of having a DSL modem, you have a cable modem which uses a protocol called DOCSIS. DOCSIS, and it stands for Data Over Cable Infrastructure. And it terminates to some sort of device in the service provider network that then interprets the signals and then provides the internet access. The advantages of the cable modem type of infrastructure is it's not distance dependent. You don't have the issues you do with DSL. It tends to be very, very high speed. You can get between 4 to 6 megabits per second. Typically, there's different upload and download rates. And it uses PPP over Ethernet for authentication. That way, someone just can't plug into a cable box or splice something in and get on the internet. The primary drawbacks to cable internet is number one, availability. If you're not in the service provider's service area, you can't get it. For instance, if your neighbors just up the street get it because they're within the service area but they don't have the cable infrastructure built down to you, it may cost a great deal of money just to stretch the cable a short distance. The other thing that you can do is you can run into a degradation problem where if your neighborhood has a heavy amount of users that actually download, for instance, a lot of very high content files, then you could actually see a degradation of service. Now, I have to say from a personal standpoint, I haven't run into that, but it is a possibility. What you see actually pictured here is very commonly the type of infrastructure you're going to see with a cable internet type of connection. You have the cable company, you have what's called an HFC connection, it's usually called hybrid fiber coax, and there's a splitter that's going to be able to give a connection to the cable box for the television stations and all the converters that are involved there, and then another that will actually be the cable modem itself, which can give you all of your data connectivity, and you obviously can put routers and things like that in to be able to do just great things in the house. With the advent of fiber optic connectivity directly into end users' homes, services such as Fios, which used to be pioneered by Verizon, now is part of Frontier Communications, and Uverse, which is an AT&T product, these actually rely on fiber optic connectivity, and they will bring in data, internet for example, TV, and so forth. So there'll be multiple services that'll be available over fiber optic connectivity. They tend to be faster, they usually require certain type of equipment, and there's varying cost factors. Now, we've talked about wired broadband connectivity, But there is a large proliferation of wireless broadband connectivity that's become available across a variety of different spectrums, no pun intended. We want to explore a little bit about what that looks like now. First, you have what's called satellite-based internet access. And this essentially, as we look at the same basic diagram that we've been looking at, you actually have some kind of an access device, usually with some sort of dish or antenna, and then there's some sort of earth receiving station that's part of the service provider's network. And then there's actually a satellite that provides connectivity. Usually you're going to have a satellite type of setup if you're in an area that doesn't have availability of DSL, cable, or Fios, or some things like that. Now, satellite access can be great because you can literally be in some very remote areas. There are some disadvantages, though. There can be issues with the satellite. There can be outages. When you have sunspots and things like that, it can interfere with that. It tends to have very high latency, meaning response time. And there's just some peculiarities with how satellite typically operates. You can have some different atmospheric interference. If it's the only type of access you have, it's obviously going to be adequate. So in addition to satellite type, you have what's called wireless or fixed wireless. You have, for instance, 3G and 4G, and this provides high-speed access over wireless media. And looking at the same type of diagram we've been talking about already, in this case you have a wireless provider that's using some sort of tower and antenna arrays that can either go directly to the personal computer in the form of some type of adapter card, or it can go to some sort of standalone device that then connects by USB or Ethernet or something like that. The different standards that are involved are CDMA, EVDO, 802.10, UMTS, and a lot of others. And there's a lot of different authentication methods that you may run into with this type of service. The speeds can range from 350 kilobits per second to 7 megabits per second, and there's a variety of different factors that can affect speed. Again, distance is going to be one of them. Now, the primary drawback is still going to be availability. In other words, the service provider being able to have the antenna infrastructures within the area you might want, and obviously other types of radio interference. So typically you will hear different cellular standards. You'll hear 1G, which is sort of an analog type of transmission, 2G, which is digital, sometimes it's referred to as edge. You have 3G, and then 4G, which typically is using an entirely different set of technologies. A company formerly known as Clearwire does a lot of 4G type of deployments. So in just sort of summarizing the various ways of being able to access the internet in modern technologies, we want to just review some important terms. The first is downstream, and this is data that flows from the service provider to the customer premise, or download is another way it's sometimes looked at. Upstream is data that flows from the customer premise to the service provider. Usually your download speed is going to be far, far greater than your upload speed. And then we talked about some different types of DSL, digital subscriber line. Asymmetric DSL, again, DSL in general is using some sort of analog phone line for connectivity. An asymmetric DSL uses different upload and download speeds. And symmetric or synchronous DSL uses the same upload and download speeds.
So were you able to pick out the access method you currently use to access the internet, or maybe have in the past? There's lots of choices, cable, DSL, and so forth. And there are strengths and weaknesses of each, which is important for you because you're oftentimes going to be recommending things to different customers and people you may work with. So understanding those strengths and weaknesses is going to be important to communicate and understand. And even better, now you have something for small talk at parties. Maybe not. Then you wouldn't get invited back. Anyway, thank you for listening. This has been a great lesson on internet connectivity.